Okay, here's those last four problems that are in your assignment. Again, I want you to have tried these problems before you watch the video, but if you're not understanding something, it's okay to watch the video to see, figure out what's going on. But if you don't try it first, you're not going to get very much out of the problem. Notice here in the first problem it says solve the triangle. That means in this case find the missing angles because you have the three sides. To solve a triangle, you find all the missing sides, you find all the missing angles. In this case, you find the missing angles. Now, right away you should know that this is the law of cosines, not the law of sines, because in the law of sines you have to have at least one angle. Usually two, unless it's the ambiguous case. So in this case, I know I'm using the law of sines. I'm going to give them some names here. So, the law of cosines. I think I just said law of sines. Law of cosines. So this is A, this is B, this is C. You know, you call them whatever you want to. You call them X, Y, and Z if you want to. So that this would be lowercase letter a, this would be lowercase letter b, this would be lowercase letter c. Let's say we want to find angle A first. So I know that a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. So I know A is 23. This is A. This is B. This is C. So I know that A is 23. So this is 23 squared is equal to 25 squared plus 27 squared minus 2 times 25 times 27 times the cosine of A. Now that's kind of a pain, but you're going to have to square them first. Don't get Mr. Calculator out to do too much all in one step. 23 squared is, let's see if I can find it here, 23 squared, I didn't write it down, let's see, 25 squared, this is 625. 27 squared is 729. 23 squared, I think it's 5. I'll just do it. 23 times 23, 9, 6, 6, 4, 529. Minus 2 times 25 is 50. Times that would be 1350, the cosine of A. So 529 is equal to, add these two numbers together first. Don't try to subtract because that's multiplied times the cosine of A. So that's a 4, carry a 1, that's a 5, that's a 1254 minus 135, or 1350 times the cosine of A. So now I'm going to subtract 1254 from both sides. So that would be, did I write it down? Did I write it down? Of course not. Let's see. That would be 5. I think this is 825. Negative 825 equals negative 1350 times the cosine of A. Double check my arithmetic here. Divide both sides by negative 1350. You're trying to find A, so you got to isolate the cosine of A. And that's going to give me the cosine of A is equal to positive 825 over 1350. That reduces, because I can see you can divide top and bottom by 25. But if I take the inverse cosine here, A is equal to the inverse cosine of this number here. I got this to be 52.33 degrees. So that's A, 52.33 degrees. Now I got to find B or C in the same manner. I only have to do this one more time because if I find B, then I can add these two together and subtract from 180 to find C, or if I find C, I can add these two together and subtract from 180 to find B. So I found B next, angle B, so that means I'm going to use B squared is equal to A squared plus C squared minus 2AC times the cosine of angle B. And so you go through kind of the same steps. This is B is 25, so this is 625 equals A, which is 529 plus C, which is 729 minus 2 times 23 times, what was the other one? 23, I'm trying to find B, so 27. Times the cosine of B. So I got the, when I solved this and I multiplied this all out, I got the cosine of B to be approximately 0.50966, which means B turned out to be 59.36 degrees. Now I took the inverse cosine of this to find that. So now I have those, so C then becomes 180 minus the sum of these two, and that turns out to be 68.31 degrees. So this turned out to be 59.36 degrees. This one turned out to be 68.31 degrees. Now it says to solve the triangle, so I would go ahead and write it all out. I mean, you already know the sides, but I would write A is equal to approximately 52.33 degrees. I would say B is approximately 59.36 degrees, and C is approximately 68.31 degrees. And then I would say, I'd just go ahead, A is 23 meters, B is 25 meters, and C is 27 meters. Now, make sure that you put the A, B, and C on your diagram there because it's not labeled. I went ahead and put the A, B, and C down so that whoever's checking my paper can see that which angles, which sides I'm referring to. All right, now, for problem number 11, this one's a much shorter problem in that they want you to find K. Now, again, it would help you, perhaps it will help you, if you draw a triangle KLM, and they give you M is 11, they give you L is 17, and they give you this angle here is 59 degrees. Side, angle, side. Side, angle, side, law of cosines. So I'm trying to find K. So I know it's typically in terms of A, B, and C, but in this case, K squared is equal to L squared plus M squared minus 2 times L times M times the cosine of angle K, which in this case is 59 degrees. So this is 17 squared plus 11 squared minus 2 times 17 times 11 times the cosine of 59 degrees. That's K squared. So I did the arithmetic here. K squared is equal to 289 plus 121 minus, if you multiply these three numbers together, you get 374 times the cosine of 59, which I got to be approximately 0.5150 using the calculator. So I multiplied these two together and then combined, I got K squared is equal to 217.38. I took the square root of both sides. You don't need the plus or minus because it's a measure. It's going to be positive, and I got this to be 14.74. Not degrees, because it's the length of a side here. That's my measurement, 2 decimal places. So this one's just kind of plug and chug. It's just that it's not one of the 3 formulas on the first page. It's a variation of it because we have different letters. That's all, but it's the same formula, just different letters. It doesn't look like the same formula. Now to do problem 12, my suggestion is to draw a picture. Now, I don't know where Halifax is. I kind of know where Chicago is. And I can kind of guess where Toronto is. I know it's in Canada, but I'm assuming Halifax is also in Canada. So it says a direct flight from Halifax to Chicago's O'Hare Airport covers a distance of 1,875 kilometers. So here's what I'm going to do. I'm going to make a diagram. I'm going to put Halifax right here, and I'm going to put Chicago right here. And this distance here is 1,875 kilometers. Then it says, because of recent changes to Air Canada, though the direct flight is no longer offered, now passengers must fly from Halifax to Toronto's Pearson International Airport first. So let's just put Toronto over here, because I know it's north of Chicago because it's in Canada. I just don't know exactly where in Canada. It says that the flight distance to Toronto from Halifax is 1,620 kilometers. Okay. It also says that the direction difference, which is the angle between the two flight paths, that's this angle right here, is 27 degrees. Look what I got. Side, angle, side. Because the question is asking for the distance from Toronto. It says how far is it from Toronto, Chicago? So I'm looking for this guy right here, which I could call lowercase letter h since it's opposite where I have the h for Halifax. So this means that h squared is equal to c squared, that's 1,620 squared, plus lowercase letter t squared, that's 1875 squared, minus 2 times 1620 times 1875, times the cosine of the included angle, which is 27 degrees. and this is kind of a mess. I punched this into the calculator and I got this to be 727,160.37 approximately. I took the square root of this and I got approximately 852.74. I didn't even check the key, so hopefully I did this right. And this would be the distance, and this is in kilometers, so it says how far is Toronto from Canada? Toronto is 852.7, is about, or approximately 852.74 kilometers from Chicago. If it's a story problem, write the answer out in a short sentence. Your teacher will appreciate it, and don't forget your units. And of course, round it to whatever they say to, and I don't think they say to anywhere in there. It doesn't say to the nearest tenth or anything like that. All right, last but not least is problem 13, which is not drawn up there because I wanted to make sure that I had enough room, so I figured I could put 13 in at the end. 13 is talking about Miss Jenkins buying some property. Now I'm going to try to draw it out. You've got it on your paper. And this is a right angle, and this is A, and this is D, and this is 240 feet, and this is 180 feet, and this is 200 feet, and this is B, and this is C, and this is 60 degrees here. And that's all we have. Mrs. Jenkins is buying some property that is shaped like quadrilateral ABCD, all the way around. Find the perimeter of the property. Well, I have 1, 2, 3 out of the 4 sides. I just don't know this one. I'll call it X. Okay? Or as it turns, yeah, that's fine. I'll call this one X. To find this, I actually need the length between B and D because I'm trying to use side, angle, side, and get the law of cosines to find this. But I need this side here from B to D, which I'll call Y. Since I have a right triangle here, I can find y using the Pythagorean theorem. 180 squared plus 240 squared is equal to y squared. Turns out y is exactly 300. This is in feet. Now you just have to go through the steps, but it is 300. This is a multiple of a 3, 4, 5. Multiple meaning I multiplied by 60. 3 times 60, 4 times 65 times 60. So that's 300 feet. Now I can use the law of cosines to find x. And x is not my answer, but x is going to help me find my answer because they want the perimeter, so it's 200 plus 180 plus 240 plus x. To find x, law of cosines, just kind of ignore this right triangle, just look at this oblique one up here. And so this is going to be equal to 200 squared plus 300 squared minus 2 times 200 times 300 times the cosine of 60 degrees. Alright, so you go through the steps here. This is 40,000 plus 90,000 minus, let's see, that'd be 60 to 120,000 times the cosine of 60, which is a half, as it turns out. So this is 130,000 if you add the first two. Minus, if you multiply here, that's going to be 60,000. So if I subtract, that's 70,000. That's what x squared is. So x is equal to the square root of 70,000, which is approximately 264.58. And that would be in feet. 264.58 feet. So now you add this, and this, and this, and this, and your perimeter, let's see, that's 420, 620, 884.58 feet. And it says find the perimeter of the property. The perimeter of the property is about, because I approximated here, 884.58 feet. Write out your answer there. I should have is about here as well, because it's a story problem and I approximated. Alright, so hopefully that helps you with those last 4 problems in case you got stuck on something, but you can always, again, give me a holler if you have a question, and I'll see if I can help you. Alright, try these problems. After you get done with this, if you have time, try these problems a second time. You've got an extra copies of the worksheet. It does not hurt to reinforce this. Law of sines, law of cosines, know when to use which. Remember, if it's a right triangle, though, you're going to use SOHCAHTOA.